Hello and welcome back to our channel. Today we will be taking a look at machine learning in the fintech industry. What is machine learning in the fintech industry? Machine learning is an application of artificial intelligence, AI, that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Machine learning focuses on applications that learn from experience and improve their decision-making or predictive accuracy over time. Machine learning focuses on the development of computer programs that can access data and use it to learn for themselves. The process of learning begins with observations or data, such as examples, direct experience, or instruction, in order to look for patterns in data and make better decisions in the future based on the examples that we provide. The primary aim is to allow the computers to learn automatically without human intervention or assistance and adjust actions accordingly. In data science, an algorithm is a sequence of statistical processing steps. In machine learning, algorithms are trained to find patterns and features in massive amounts of data in order to make decisions and predictions based on new data. The better the algorithm, the more accurate the decisions and predictions will become as it processes more data. How does machine learning work? There are 4 basic steps for building a machine learning application. These are typically performed by data scientists working closely with the business professionals for whom the model is being developed. The first step is to select and prepare a training dataset. Training data is a dataset representative of the data the machine learning model will ingest to solve the problem it is designed to solve. The training data needs to be properly prepared, randomized, deduped, and checked for imbalances or biases that could impact the training. The next step is to choose an algorithm to run on the training dataset. Again, an algorithm is a set of statistical processing steps. The type of algorithm depends on the type, which would be labeled or unlabeled, and amount of data in the training dataset and on the type of problem to be solved. The third step would be training the algorithm to create the model. Training the algorithm is an interactive process. It involves running variables through the algorithm, comparing the output with the results it should have produced, adjusting weights and biases within the algorithm that might yield a more accurate result, and running the variables again until the algorithm returns the correct result most of the time. The resulting trained, accurate algorithm is the machine learning model. The fourth step is using and improving the model. The final step is to use the model with new data and, in the best case, for it to improve in accuracy and effectiveness over time. Where the new data comes from will depend on the problem being solved. For example, a machine learning model designed to identify spam will ingest email messages, whereas a machine learning model that drives a robot vacuum cleaner will ingest data resulting from real-world interaction with moved furniture or new objects in the room. There are a few different machine learning methods. Machine learning methods, also called machine learning styles, fall into 3 primary categories. Supervised machine learning. Supervised machine learning trains itself on a labeled dataset. That is, the data is labeled with information that the machine learning model is being built to determine and that may even be classified in ways the model is supposed to classify data. For example, a computer vision model designed to identify purebred German Shepherd dogs might be trained on a dataset of various labeled dog images. Supervised machine learning requires less training data than other machine learning methods and makes training easier because the results of the model can be compared to actual labeled results. But properly labeled data is expensive to prepare, and there's the danger of overfitting, or creating a model so closely tied and biased to the training data that it doesn't handle variations in new data accurately. Unsupervised machine learning. Unsupervised machine learning ingests unlabeled data, lots and lots of it, and uses algorithms to extract meaningful features needed to label, sort, and classify the data in real time, without human intervention. Unsupervised learning is less about automating decisions and predictions, and more about identifying patterns and relationships in data that humans would miss. Take spam detection, for example. People generate more email than a team of data scientists could ever hope to label or classify in their lifetimes. An unsupervised learning algorithm can analyze huge volumes of emails and uncover the features and patterns that indicate spam, and keep getting better at flagging spam over time. Semi-supervised learning. Semi-supervised learning offers a happy medium between supervised and unsupervised learning. During training, it uses a smaller labeled dataset to guide classification and feature extraction from a larger, unlabeled dataset. Semi-supervised learning can solve the problem of having not enough labeled data, or not being able to afford to label enough data, to train a supervised learning algorithm. Reinforcement machine learning algorithms is a learning method that interacts with its environment by producing actions and discovers errors or rewards. Trial and error research and delayed reward are the most relevant characteristics of reinforcement learning. This method allows machines and software agents to automatically determine the ideal behavior within a specific context in order to maximize its performance. Simple reward feedback is required for the agent to learn which action is best. This is known as the reinforcement signal. Deep learning. Deep learning is a subset of machine learning. All deep learning is machine learning, but not all machine learning is deep learning. Deep learning algorithms define an artificial neural network that is designed to learn the way the human brain learns. Deep learning models require large amounts of data that pass through multiple layers of calculations, applying weights and biases in each successive layer to continually adjust and improve the outcomes. Deep learning models are typically unsupervised or semi-supervised. Reinforcement learning models can also be deep learning models. Certain types of deep learning models, including convolutional neural networks, CNNs, and recurrent neural networks, RNNs, are driving progress in areas such as computer vision, natural language processing, including speech recognition, and self-driving cars. Real-world machine learning use cases. As noted at the outset, machine learning is everywhere. Here are just a few examples of machine learning you might encounter every day. Digital assistants, Apple's Siri, Amazon Alexa, Google Assistant, and other digital assistants are powered by natural language processing, NLP, a machine learning application that enables computers to process text and voice data and understand human language the way people do. Natural language processing also drives voice-driven applications like GPS and speech recognition, speech-to-text, software. Recommendations. Deep learning models drive, people also liked, and just for you, recommendations offered by Amazon, Netflix, Spotify, and other retail, entertainment, travel, job search, and news services. Contextual online advertising. Machine learning and deep learning models can evaluate the content of a web page, not only the topic, but nuances like the author's opinion or attitude, and serve up advertisements tailored to the visitor's interests. Fraud detection. Machine learning regression and classification models have replaced rules-based fraud detection systems, which have a high number of false positives when flagging stolen credit card use and are rarely successful at detecting criminal use of stolen or compromised financial data. Cybersecurity. Machine learning can extract intelligence from incident reports, alerts, blog posts, and more to identify potential threats, advise security analysts, and accelerate response. Self-driving cars. Self-driving cars require a machine learning tour de force. They must continuously identify objects in the environment around the car, predict how they will change or move, and guide the car around the objects as well as toward the driver's destination. Virtually every form of machine learning and deep learning algorithm mentioned above plays some role in enabling a self-driving automobile. Machine learning enables analysis of massive quantities of data. While it generally delivers faster, more accurate results in order to identify profitable opportunities or dangerous risks, it may also require additional time and resources to train it properly. Combining machine learning with AI and cognitive technologies can make it even more effective in processing large volumes of information. Thank you for watching. If you enjoyed the video, please like and subscribe so not to miss out on more.